I've worked with a lot of contractors, both expatriates, and I've worked with Nigerian engineers, and I've seen some issues, some problems, and due to the problems I see and looking to the future of engineer, we had to design this webinar so that engineers will understand the need, why they need to understand smart designs. Yeah, we know that across the world, organizations are focusing on the right combinations of advanced technology. So every company at this particular point wants to build a product whereby they can use technology to drive their operational efficiency. So they want to get a smart design. They want to get an automated system that can help them to solve problem with lower time. And for the industry, like for the manufacturing industry, they want devices that can give them good operational efficiency and reduce downtime. So as we know, engineers are the foundation of the economic and social development for Africa and beyond. They cannot be laid without first equipping themselves with enough skills. So as engineers, we need skills. We need skills. And the reason why we're talking about this is because Africa as a whole and Nigeria as a whole, we are part of the developing country, like Nigeria is part of the developing countries. So sometimes I see some companies who call in expatriates to come and do jobs, and we still have engineers who are graduates and still don't have job. I discover about 90%, because I go to a lot of industries. I've worked for over like 12 industries in Nigeria. I've done one job or the other for them. So anytime I go to the industry, I discover that even the graduates are employed, and at the end of the day, they give them this role of, oh, you are maintenance engineer. So they just go to the equipment, they maintain the equipment. Why, if those equipment have any issue, the first thing they will do is to call the expatriates abroad. So they'll fly the expatriate abroad down to Nigeria to come and carry out those jobs. Why? Because they feel they are not safe with those engineers carrying out the job. I'm not saying all engineers are like that, but I'm just saying that majorities of engineers don't actually. Please, I would like us to mute if we are not speaking. So I'm sorry for that. Let me just mute whoever is disturbing us at this point. So so a lot of engineers in the industry don't actually practicalize. So I was speaking with a contractor that was on Friday, and he has a very good technology for a very good company. I was called to consult for that particular company. And I was speaking to the contractor, he was presenting, yes. While he was presenting, I discovered something about the technology. Yes, his technology is fine, but it's not good for Nigeria. It's not good for Nigerian climate. It's not good for Nigerian environment. So sometimes the expatriate brings in technology which are good, but are not really efficient. So we engineers in Nigeria, we engineers in Africa understand our environment, we understand the problems, we can tell, we can relate. I guess someone that in terms of, let me look at the power sector itself. Okay, someone who stays in abroad and works in abroad, now if he comes to Nigeria and he wants to open a company. If he wants to open a company, maybe an energy company, he wants a solar system and he wants to build something like a mini grid around where people can be able to connect, maybe different communities can be able to connect to the mini grid, to his mini grid. So if he doesn't look at his environment, if he brings in the model from outside the country, maybe like somewhere like US or London into Nigeria, and wants to implement that same design here in Nigeria, I tell you that design might not work. So I was actually planning a model with some startup companies, and they were looking at building an energy company. But looking at this energy company, they wanted to implement an automated design, and one of their idea was to help people sell their energy. So if I have a solar panel in my house and I want to travel for 1 year, or maybe I want to travel for 2 months, or I want to travel for 1 month, how can I sell down my energy? Yes, they do it abroad. So how can I sell? How can I convert that? How can I connect that energy into the grid? And I was trying to explain to them that yes, they can easily do that abroad, but coming here to Nigeria, I'm not saying that cannot be implemented. I'm not saying that, but there are some factors you have to put in place when carrying out your designs. So, and most of these designs, we as engineers need to be involved in them so that we can have a very sustainable development in the country, can have a very sustainable business for them also, so that they can also have a very sustainable business. So if someone comes in from abroad and say he wants to give everybody energy, he will install energy and he wants you to sell back to the community, my dear, there is energy theft in Nigeria. The person will connect and tell you that he has not connected, or the person will bypass what you have connected and tell you that he didn't use the actual energy. So all I'm trying to say is that we engineers are the ones to carry out this design, and we need the right skills for us to carry out this design. Yes, because the truth about it is that technology is increasing as a fast, very, very fast. It's increasing very, very fast. So I'll just share some of the skills we need to have. So I don't know if I know we might have heard of some of these technologies, but these are where the design, when it comes to engineering, is tending towards to. So as engineers, we need to play a role in ensuring that we have the skills, ensuring that we have this knowledge. IT world, they are doing great, but there are some things they cannot design because they didn't study engineering. But because we study engineering, we can use our basic principle and say, okay, this is how it should be, this is how it should be, this is where your programming is going to come in and all that. So the first one is E2E. E2E means end-to-end, and MBS means model-based design. So this is a skill. So there's a skill you can get on how to model designs, on how to model different designs, so that when you put them together, they can be able to check for errors and be able to give you adequate solutions for that, your particular project. So there is also robotics. Then there is immersive technology. There is, these days we are hearing of augmented realities, whereby the operator does not need to enter the plant. All he just needs to do is to get, like Siemens had to do what I call this. I'm sorry for that. I don't know why I stopped. I'm sorry for that. Yeah, so I guess it's due to bad network. So I'm sorry for that, just to my network. So I would just share back the screen. So I hope we can, want someone to just let me know if you guys can hear me. Okay.
Yes, I can hear you from here.
All right, I believe we can all hear me. So all these are skills. So end-to-end model-based technology. So if we go an in-depth into, I won't go an in-depth into all these technologies, but these are technologies that we need to have. These are skills we need to have. These days you can get materials online, you can read, you can study and find out companies that are trying to implement this. You can get people, there are a lot of jobs that, I saw a job recently of a friend who sent me a link of a particular job, and I saw a lot of technology that the company was requesting for, and I knew that all these things the company is requesting for, you can't get them in the university. You can't get them in university, but you need your university knowledge, the major principles, so that you can apply this technology. So when you have understanding of the technology, you can be able to bring designs that fit your environment and will be sustainable. So the second one, like the immersive technology, has to do with augmented reality. We have the robotics. We have generative designs. We have user experience interface. That has to do with SCADA. These days, clients want to be able to monitor their plant remotely. Clients want to be able to control. So they build what I call SCADA. I believe most of us must have heard the word SCADA, which is supervisory control and data acquisition. So it's the platform, the control, central control platform, whereby you can be able to control your processes. You can be able to control either your plants. So SCADA can be implemented in any kind of SCADA can be implemented at any point, at any kind of technology. So I've worked with some SCADA technology, and I'll tell you that the customers are always wow with the technology. They're always wow with the technology because from their house we can monitor. So I was involved in a project. I think that was a first smart traffic system we did for in Lagos at Allen. If you're in Lagos and you normally pass Allen, so that traffic system there. So there's a camera that counts the numbers of cars and send an input to a controller that tells, okay, increase the time or reduce the time. And you can see it from your office. You can see the camera of the 4 junctions from your office. You can say, okay, let the traffic lights, okay, you can stop the entire traffic light to be red. So people want to have an interface where they can interact with their business, whereby they can interact with their job. So during the lockdown, there was an issue because during that point, a lot of expatriates couldn't come into the country to carry out one job or the other. So different companies had to look at the local automation engineers. And a lot of automation engineers at that particular point in time made a lot of money from them because companies don't want downtime. So currently, I believe we have heard of AI, artificial intelligence. So all those methodology, we have heard of big data and analytics. We have heard of robotics. We have heard of robotic process automation, whereby robotics carry out the process for you automatically without you trying to check. And when all these technology are put in place, they give you very smart designs. They give you very good products. And this is what our society needs so that we can develop as a country. So smart design is all about leveraging latest technologies to carry out your design. So I'll be talking on analog system and digital signals, so which is just a subset. So one of the things I've discovered in the industry is that most engineers find it difficult to understand these two concepts. I believe if you're an electrical engineer in this Zoom meeting, you must have heard of analog signals or digital signals. So for you to be able to remotely monitor anything, so automation is just the use of technology to solve human problems. It's trying to reduce the efforts. So automation will help you to reduce that effort. So instead of you going to do that processes by yourself, automation will help you carry out those processes. So I've seen some engineers, and when they're trying to bring automation into their processes, they always have issue when it comes to these two words, analog signals and digital signals. And it's very important. It's very, very important. So I can remember of a particular job I went for. I was called to do. So the guy called me. Yes, he's a graduate of electrical engineer. He called me and he told me that the factory has issues, and he told me that they are using PLC, which is called Programmable Logic Controller, which is a controller as well. So he told me that that factory has PLC issue. So I told him no problem, that he has to pay 30,000 naira before I leave the office. So the guy said he's going to pay. On going to the factory, I saw another device entirely. And the device I saw entirely was different. I wouldn't have, if he told me that it was that device, I wouldn't have charged him the 30,000 naira. So all I'm saying is that guy made their company pay 30,000 naira because he was ignorant of the device he was using in industry. So a lot of companies want to drive automation in their system. So whenever they want to drive automation, the first thing that comes in mind is, what do I need to monitor? So once what do I need to monitor comes in your mind, the next thing is, how do I monitor this thing remotely? So then how do I capture them? So for you to capture this thing, you need to get signals. So the kind of controller and the kind of design you would make depends on what kind of analog signals you want to get or what kind of digital signals you want to get. So as we know, analog signals are time-varying signals. generally bound to a range. It can be from 12 volts to 14 volts. So it's a signal kind of. So let me just explain using Lee terms. So if I say, maybe if I want to monitor the voltage, if I can monitor when the voltage is fluctuating, like if you can see, I don't know if we can see my mouse, if we can see how this analog graph here is showing. So I can be able to get each monitoring of that particular voltage. I can be able to get when the voltage is 192 volts. I can be able to get when the voltage is 200. I can be able to get when the voltage is 250. I can be able to get when the voltage is 35. So I will be getting a real-time monitoring. So if I want to measure temperature, I should be able to get the amount of temperature at that particular time. So if someone is in UK and the person wants to monitor that remotely, the person should be able to see the amount of temperature at that particular factory or that particular product is doing at that particular time. So that's real-time monitoring. So for things like sound, for things like temperature, position, major, and other physical phenomena, stuff like level, frequency, current, voltage, if you want to monitor them remotely and you want to get their real time, you can only monitor them via analog signals. So there are some devices that can monitor this thing via these signals via analog and convert. So we have the analog signals. We have devices that can convert from analog to digital, and we have the one that can convert from digital to analog. So when we look at the digital signals, the signal that represent data as sequence and as discrete also. So these are signals that takes that understand 1 and 0. So either the light is off or the light is on. Either the fan is on or the fan is off. So they only take 1 and 0. So if I want to measure 20 bags of cement that they are producing in the industry, and I want to get how many bags of cement produced in a day, so I can get a sensor at that particular point, whereby the sensor will be counting each bag of cement at each particular time. Or I can get a sensor at a door that can count the amount of people that enters a particular room. So that is a digital signal. But if I want to get an analog signal, maybe for a temperature range, and I need to get the temperature changes at real time, I know that what I'm dealing with is an analog signals. So let me look at, if we look at maybe trying to create maybe an energy solution for a company, and we're trying to measure the energy. So we need to we'll be dealing with voltage and current, and we need to know the real time, because we need to know the energy per time, so that we can know how much that particular location is consuming at that particular time. So the kind of signals we use is called the analog signal. So there are certain projects, whatever project that has to do with remote monitoring, always consider these two things, analog signals and digital signals. What do you want to measure and how are you going to measure them is very important. So we make use of automation in industry. So the manufacturing industry is one of the biggest industry where automation is being applied. We make use of a lot of controllers, PLC. So there will be a course later where I will come in and I'll talk about automation, and I'll talk about the levels of automation and also different control systems and how they function. So in industry, we make use of this. PLC are being programmed. So we have various kind of PLCs. We'll talk later in this meeting. So even I was involved in automated smart homes where everything in the building wants to be smart. So if I want to have a smart home, I need to also consider which kind of signals am I monitoring? How am I going to monitor them? I need to understand each sector. Is it the temperature? Is it the blind opening? So if I look at the temperature, I know that that's an analog signal. If I look at the blind opening, I know that's a digital signal. So how do I program this? How do I integrate different devices? How do I bring in, okay, maybe I just buy, let me say I just buy a fridge, or maybe let me say I just get a sound, or maybe, okay, let me put it, maybe I just get a particular light, floodlight, and I want that light to come only at night, or I want the camera to come only at night. If I install it outside and I want the light to come on and off, that's a digital signal. So if I understand this, I'll know how to integrate this down to the controller as an automation engineer. So the future of work is now globalization and digitalization, and other mega trends are bringing radical shifts to how we live and how we work. So what are we doing right now as engineers so that we can learn, so that we can be in tune with how much changes that is